In this video, we're going to focus on solving exponential growth and decay word problems. So let's get right into it. In 2005, there were 1,000 rabbits on an island. The population grows 8% every year. At this rate, how many rabbits will there be on the island by 2020? So what should we do in this problem? How can we find the answer? So we need to write an equation. Now, is this an exponential growth or decay problem? Since the population is growing, it's an exponential growth problem. The equation that you want to use is y is equal to a times b raised to the x. This is basically the generic formula for exponential growth. But for this particular problem, a is going to represent the initial population, b is going to be 1 plus r raised to the t since we're dealing with time. So the initial population of rabbits is 1,000. It grows 8% every year. 8% is basically 0.08. To convert a percentage into a decimal, divide by 100. So 8 divided by 100 is 0.08. Now what should we plug in for t? How many years will pass by between 2005 and 2020? If we subtract the two numbers, it's going to be 15 years. So let's type this in the calculator. 1,000 times 1.08 raised to the 15th power. You should get 3,172 rabbits, rounded to the nearest whole number. The value of a new car in 2015 was $40,000. It depreciates 7% each year. How much will the car be worth in 2024? So go ahead, take a minute, pause the video, and work on this problem. See if you can do it, and then unpause it when you're ready to see the solution. So let's begin. So what equation do we need? What we have here is an exponential decay problem because the value of the car is decreasing over time. So the equation is going to be similar to the last equation, but instead of 1 plus r, it's going to be 1 minus r due to the fact that it's a decay problem. So in this case, a is going to be the initial value of the car. It's 40,000. And it depreciates by 7%. 7 divided by 100 is 0.07. And what is the value of t? So we know we need to subtract 2024 and 2015. That will give us a difference of 9 years. 1 minus 0.07 is 0.93. So let's type this in the calculator. So 40,000 times 0.93 raised to the 9th power should be about $20,816.44. So this is going to be the expected value of the car 9 years later. John bought a new home in 2002. The value of the home increases 4% each year. If the price of the house is $225,000 in 2015, how much did he pay for it in 2002? So is this an exponential growth or decay problem? Since the value of the home is increasing every year, it's an exponential growth problem. So therefore, the formula that we need is going to be 1 plus r instead of 1 minus r. Now, what are we looking for in this particular problem? Notice that the 225,000 occurs in 2015. That's the present value. And we're looking for the price of the home in 2002. That's the value in the past. So let's say if a represents the present value, y represents the future value. So I'm going to write PR for present and FUT for future. Now in this problem, y represents the present value. which means A represents the value in the past. So A is always the value that occurs sometime before Y. Y is the value basically after some time beyond A. So we have this situation for this problem. Hopefully I didn't confuse you on that. So in 13 years, the value of the home increases to 225,000. We need to find out how much it was worth 13 years ago. R is going to be 0.04, and T is going to be 2015 minus 2002, which is 13. So let's find out what this value is equal to first. 1.04 raised to the 13th power is about 1.6650735. So let's divide both sides by this number. So A is equal to 225,000 divided by 1.6650735. So John, he purchased a home for $135,000 and $129.17, according to this formula. So that's how much it was worth in 2002. Let's work on this problem. A sample contains 1,000 counts of bacteria. The bacteria doubles every 20 minutes. At this rate, how many counts of bacteria will there be in 3 hours? So if you get a question like this on a test, what will you do? So we know this is an exponential growth problem. Now we want to use this form of the equation, y is equal to a times b raised to the x, but we're going to modify it. Just as before, a represents the initial amount, in this case the 1,000 counts of bacteria. B represents the growth. The bacteria doubles, so B is equal to 2, and A is 1,000. Now the bacteria doubles every 20 minutes. Typically, X is usually represented in hours. You can make it minutes if you want, but since I'm looking for the amount of bacteria in 3 hours, I'm going to use hours. So if X represents the time in hours, or T, and it doubles every 20 minutes, then it doubles 3 times in an hour, because there's 3 20-minute periods in an hour. An hour is 60 minutes. If you take 60 minutes divided by 20, this is going to be 3. So the equation is going to be n times t, where n is the number of times it doubles in an hour. In this case, n is 3. So let's plug in what we have. The equation is now y is equal to 1,000 times 2 raised to the 3t. And t is 3 hours, so 3 times 3 is 9. So it's going to double 9 times. It doubles 3 times in an hour, but 9 times in 3 hours. 2 to the 9th power is 512. Multiplied by 1,000, so there's going to be 512,000 counts of bacteria in 3 hours. A sample contains 100 counts of bacteria. The bacteria triples every 15 minutes. So let's write the equation. We can see that A is 100, that's the initial population. Now the bacteria triples, so B is 3. And it does so every 15 minutes. So how many 15-minute intervals are there in a single hour? Well, 1 hour is 60 minutes, and if we divide that by 15, this is going to equal 4. So the equation is 100 times 3 raised to the 14, where t is in hours. So let's answer part A. How much bacteria will there be in 1 hour? So t is 1. 3 to the 4th power is 81, and 100 times 81 is 8100. So that's how much bacteria there will be in a single hour. Now let's focus on the second part of the problem. How long will it take for the sample to contain 500 million counts of bacteria? So we need to solve for t. T represents the time. So in this case, y is 500 million. We can write that as 500 times 10 to the 6. Now what's the first thing that we need to do in order to solve for t? The first thing that we should do is divide by 100. 500 divided by 100 is 5. Now what's our next step? In order to solve for t, we need to use logarithms. Let's take the log of both sides. Now, a property of logs allows us to take the exponent and move it to the front. So what we now have is log 5 times 10 to the 6, and that's equal to 4t times log 3. So let's divide both sides by log 3. So log 5 times 10 to the 6, well, let's divide it by 4 log 3. Let's get t by itself. Divided by 4 log 3 is equal to t. So if you have your calculator with you, type in log 5 times 10 to the 6. You should get 6.69897. Log 3 is about 0.47712. If you multiply that by 4, on the bottom you should have 1.908485. Now let's divide these two numbers. This will give you 3.51. So it's going to take 3.51 hours for the sample to contain 500 million counts of bacteria.